Okay, if you did not watch the lesson on 2.6 yet, you definitely want to watch that before you continue on with this lesson. This is 2.7 derivatives, and the formulas here, I'm just going to briefly read them because, again, you should have gotten these in the last video. So this is, again, from section 2.6, where we learned that the slope of a tangent line is the limit of the slope of the secant line as the one point gets closer and closer to the point of tangency that we desire. Now also, if your original function was the position function, s equals f, a function of time, then your velocity at a specific time is just that derivative quotient, or limit quotient, again, with the time plugged in for a. And all of these, and any limit that looks like this, the limit of f of a plus h minus f of a all over h, those are any rates of change. So it could be position versus time. It could be cost versus units. It could be, anything at all. It just gives you an instantaneous rate of change. Okay, so one new term that you want to know right now is derivative. Okay, so our derivative of a function f at a number a, denoted by f prime of a, is given by this formula. So again, I'm going to go through this pretty quickly. Pause if you want to, or go back to 2.6. You've already learned that formula. And again, you read this f prime of a. Graphically, remember, here's where the two formulas came from. We can label our point where we want our tangent line with an A, and then we can label some other point indicating that this point here is a plus h, f of a plus h. Again, from section 2.6. So if that's the case, then our y minus y over x minus x gives us an a plus h minus a, which makes the a go away, and that's where we got this. This is the slope of the tangent line at the point P. And similarly, we could instead look at our point A, but graph our other point, or label our other point just a plain old x. So then this point is x, f of x. So then when we get the slope of that secant line, we have f of x minus f of a over x minus a. And again, that comes from, in a slower, more detailed explanation in section 2.6. And then this just talks about, okay, now how are we going to find the equation of the tangent line? And it just comes from point slope. So let's actually try an example. Again, this is just a reminder of this formula. So since it's right here on this page, let's use this formula to find the derivative of this function at the generic number a. Okay, that means we can plug any number in for a later. So we're going to say, okay, f prime of a is the limit of f of x minus f of a over x minus a. Now here's the tricky part. You have two formulas. You can use this formula, and here comes my, whoops, you know what? I made a mistake. Normally I would say for part of your assessment for tomorrow, find my mistake, but I just found it and I'm going to fix it. That should have been 8a minus 9. So f of a is just, this thing with the a plugged in. Okay, so going back to the simplifying here. In order for us to simplify this, if we want the limit of this as x approaches a, well, you see right now that you get a 0 if you plug a into the bottom, and you would end up with a 0 on top if you plugged a in for x up there. So that's going to give us 0 over 0, which is an indeterminate form. That's not good, so we have to do something else algebraically. If you consider distributing this minus sign through, all that's going to happen is your 9's are going to be gone, and then you'll have x squared minus a squared minus 8x plus 8a all over x minus a. And you're going to have to either use long division or just figure out how to factor that numerator so that x minus a cancels out. Is that going to be easy? Maybe, maybe not. So you can try it that way, or let me show you that you can actually start out with another formula. So I am going to, since I don't have an eraser, I'm just going to kind of get rid of what's here and start with a different formula. Here's my different formula. It's the one from the other page, so you can pause and go back if you want to, because I actually can't turn the page here. If I turn the page, then you're going to lose what's here. Alright, so I could also use f prime of a equals the limit as h approaches 0 of f of a plus h minus f of a all over h. Now let's see if that's any easier here. And it always depends on the question as to what's going to be easier. So f of a plus h is going to give me a plus h quantity squared minus 8a plus h plus 9. Now, f of a is going to give me minus a squared minus 8a plus 9. And this is all over h. Okay, so now let's simplify this. Limit as h approaches 0 of a squared plus 2ah. I might run out of room, so it's going to get a little messy. Minus 8a minus 8h plus 9. Now distribute your minus sign through all over h. Now, as messy as that was, let's see what happens now. I have an a squared minus an a squared. I have, let's see, a 9 minus a 9, and I have a negative 8a plus 8a, which means, what do I have left? A 2ah, that looks negative, but it's not, it's just messy, plus h squared minus 8h all over h, and now I can factor an h out of the numerator, cancel it with the h in the denominator, and substitute, if you will, right? We're going to use direct substitution to put 0 in for h. So when I take the limit, I actually direct substitute that in, and I'm going to get 2a minus 8. Now, I'm going to stop here, and the first thing that I'm going to ask you to do tomorrow, or to show me, it might be a ticket in the door, let's say, is to go back to that other formula and see if you can finish it. We started it, right? And then I erased it, and then we used the other formula. Maybe it won't even be something that you have to do, but let's just say for some extra credit tomorrow, let's see how good your algebra skills were, and walk in with that already done. If you can come down and show me this same problem, and here you already know the answer, right? If you could show me that same problem with your solution but using the other formula, I'll give you a bonus point. Some of you need the redemption after today. All right, I'm going to pause here. I have more notes, and I will finish these when I get home. I'm still not home. It's about 20 after 6, so I'm going to put these on the website, and you'll be responsible for this much for tomorrow, and hopefully you can watch the rest of the video, but it is going to be kind of late by the time it's all done. So at least finish this for tomorrow. Okay? Again, try the other formula for yourself. If you want, we're then going to take this one step further and find the equation of the tangent line to here at this point. So you just need to figure out, okay, what was my exact slope? That was a rule for finding a slope. Figure out now, because a is 3. Figure out what your exact slope is, and then if you have a slope and you have a point, which you do, then you can find the equation of the line. All right, I'll try to get more up later.